Hello, everybody, and welcome back. Hope you enjoyed a quick lunch break. We are now in room 3, and we will be talking about TSQL best practices with Ben Miller. If you have any questions, please put them in the box on the right-hand side of your screen or in the Slack room under BMDD_room and the number 3. Go ahead.
Thanks. Hi, everyone. Hopefully you're ready for some fun. You've already got a day and almost a half underneath you, so you only have this afternoon left. So hopefully it'll be great. This presentation has been around for a long time. I've kind of tried to modernize it, but this is meant to be a fun interaction with TSQL and some of the best practices. There's probably a day's worth of content that I could provide for this type of topic, but for now we're going to do some really good ones. You feel free to type in the chat the questions if you want to, and later on I'll be hanging around the room 3 to answer any questions afterwards. So let's get started. The only thing that you need to worry about on this slide is the ben@benmiller.net. That's my email address. You're welcome to email anytime. I am open to whatever. So just email me and let me know if you have any questions today, a year from now, whatever. My LinkedIn and Twitter is down on the bottom so that you can get that. The slide deck will make sure you get a hold of that as well, so you have it without having to scurry and write down things really quick. This is the agenda. It looks a little long, but we're going to try to go. It's going to be a little fast paced, but mostly because some of the things won't necessarily be necessary to tell everything about it and make sure that you have all the things you need. So first, we're going to talk about assignment statements. Those are the most basic, but very important to know how things work. There's a few nuances. And then schema and qualifying objects will be a forever subject that we'll cover and why. Case insensitivity. There's many, I've been encountering more and more instances that are actually case sensitive, and there's some things you need to know about that to how to keep you safe when you're developing TSQL. Data types, very, very important. We'll talk about those. Triggers are becoming more popular as well with data warehousing and other things that happen, but there's also a lot of business logic that people are putting into their SQL servers. So triggers become very important, and there's very common things that happen inside triggers that make them invalid. And so we're going to talk about that. Identity and sequence. Identity is the old guy. Sequence is the new guy. We'll talk about what that is and why you should care. And then SARG, search argument. We call it SARGability. We're going to talk about that because that's a really big deal. And then using features for the version of SQL Server. There's a lot of new features since 2008 R2, which seems to be the de facto people migrating from that version. So there's plenty of new things to take advantage of as we go. We'll talk about versions as well. All right, let's talk about assignment statements. So this is maybe fairly insignificant to many if you've done any TSQL, but there's 2 ways, actually 3. And in this slide that says 4. So there's 4 ways to actually set a variable equal to a value. So the first 2 are set versus select. Those are the ones you see most often. And that's just because they're very common. Set is a single assignment. That is an ANSI standard word that you can only set one and only one value to one and only one variable. So that's going to be important. If you use that and you have 20 assignments that you're going to do, you might want to use a select, because that means 20 set statements have to be executed, which, think about cycles that you're burning. Every time you execute a command, SQL has to deal with it. So set will do one at a time. Means you'll burn 20 cycles. In a select, it actually is executed. It might burn a few more cycles than one, but depending on how many you have. So if you select and then set the value equal to the variable equal to the value 20 times in one select statement, is one execution. So it may take 2 CPU cycles, but it certainly won't take 20 for 20 statements. The other way is if you're going to declare constants and you're going to just use them below, or you're going to have a variable that is going to contain a value that's going to be used throughout the piece, and you just set it, then you can do it in the declare. So as soon as you declare the variable, you can actually say equals 5 or equals to your value. This is since 2008 on. So at 2008, this became a thing that you could actually set it. 2005, you can't do that. But hopefully you're all at least 2008 and above. So this is a very valid statement, and you can string them together. So you can declare variable type equals something, comma, variable type equals something, and keep on going. In one statement, you don't have to do 5 declares. You can do declares with commas separated. So it really helps you out. The other one that most people don't see, and I've only seen it one place, that Microsoft uses this statement update to set values to a variable in the ASP.NET state provider. So I had never seen it before. I was cracking open a stored procedure that they had written, and I was going to see if we could tune it. And I came across this update statement, and we'll show you what that looks like. It's really odd, but it's kind of fun. The most important thing for assignment statements, don't mix and match all over the place. If you're going to use set or select, the only time you'd use set is if you wanted to throw an error, if you were doing a subquery. And we'll talk about that in the demo, but that's the only time you'd mix and match. The reality is, being consistent is not necessarily friendly to SQL only. It's more friendly to you. When you go back and modify your code and you have them strung from heck to breakfast, you set use here and select in the middle and then declares and update. I mean, you're just not going to be able to follow the logic very well. So consistency really does rule the beast here. So that's the big message on this assignment statements. Schemas and qualifying, there's a lot to be said about this, but it's very simple. The reality is that people in Oracle never have to, they don't usually specify the 2 parts to their name, because the schema in Oracle is the user. Now that was brought over to SQL Server, and SQL Server has what they call a default schema. And in SQL Server, if you default your schema to DBO and your table is in DBO schema, then you feel good about not doing that and not qualifying it two sides. The reality is, it is going to impact you when certain conditions happen, and you can decide whether you care or not. But I'll tell you that the big deal about this is, say you have DBO schema right now, and tomorrow, or we'll just say a year down the road, they decide they want to put everything in a schema and not DBO. You have a lot of work to do if you've had stored procedures or views or triggers that don't at least qualify your objects 2 times. Now, it doesn't preclude you from having the switch of the schema being DBO to Bob. It doesn't change your stored procedures. What it does is it gives you a place that you can search for DBO dot and replace it for Bob dot or something. But the bigger piece here isn't about the naming convention of switching schemas. It's really about SQL Server and how it acts. So the behavior of SQL Server when you do not specify a schema and you only specify the table name, view name, stored procedure, whatever, is that SQL has to qualify that to make sure it knows what valid objects there are. You can have the same named object in 2 different schemas, and it's completely valid. There's no wrong or right in it as far as SQL is concerned, because the 2 parts will make up that object. In fact, objects really have 4 parts. If you look at the slide, it's server.database.schema.object. The difference is that in SQL Server, it tries to be friendly to you in that if you don't specify a schema, it will look up your default schema as a user. Now, if you just create a user and you don't specify a schema as the default schema is your username. So if my username was Ben and I created me a user, granted me access to the database, and did not set a default schema, my default schema is Ben. So what SQL does when you query an object called people under the Ben schema, and I have, or the DBO schema, sorry. If you have the DBO schema and my object name is Ben, as soon as I query select star from Ben or people, as soon as I do that, SQL has to qualify that beyond the first object name, because the 2 parts are really what it needs, a minimum of 2. So it will go out and look at your default schema as a user and say it is Ben. It will search in the schema objects and see if it can find a people object in the schema Ben. It fails, and then it defaults back to DBO. It'll always default back to DBO, which is why people figure out, hey, you know what? I'm just going to leave it off. It's less typing. I don't have to worry about it. What happens is SQL will search for it. Now, if you already know that that object is dbo.people, just put the dbo.people and save SQL a lot of hassle, because it's not going to be happy when you start doing things that make it work harder than it should, and something about the SQL Server that you already know. So the other thing to note is default schema is now available for groups. I believe that was done in 2014. So now your schema can actually be specified for a group now, where it was used to be just users. And most of us use groups for authentication and authorization now anyway. So that's a good plus. Case insensitivity. Most people don't really realize. I mean, a lot of DBAs that grow up in accidental DBA roles or just haven't been around SQL that long don't realize that every database has a collation, a default collation. SQL Server also has a default sort order. When you install SQL, you can actually change your sort order for the SQL Server. If you choose one that is a CS, which is a case sensitive, or binary, which is obviously case sensitive because it's done by binary numbers, that becomes case sensitive. So when you think about case insensitivity, you might think, oh, it doesn't matter. I use an application and all is well. And what if you create stored procedures from one server, even management stored procedures that you use, if you port them over to a case sensitive server, and here's how I find out really fast whether it's case sensitive, is I always install SP who is active. And SP who is active has SP underscore who is capitalized, is capitalized, and active is capitalized. So when I go into a server and I say SP who is active with just all lowercase, it comes back and says, I'm sorry, I can't find that stored procedure. So now I know that there is a element of case sensitivity in this server, and I change it to SP proper case who is active, and sure enough, it works. So the problem with this is, and Adam Mechanic did a very good job because all of his stuff works on case sensitive or case insensitive because he developed to definition. He developed all the fields that he plays with, all the variables he plays with, all of the things he did are all in case sensitive mode. So he can port this to a case insensitive server. He can port it to a case sensitive server, and it all works. So the key here to be friendly to SQL and really to yourself is to code to definition. If you do proper cases in your code. If you use SQL Prompt or any other tool from Apex or anybody else that does the advanced or help you code, you can turn on these things to do proper case that is in your definition. So that's a helpful thing as well. Data types is a really big one, in my opinion. It happens all the time whenever you're tuning a query or doing things like finding out whether or not things are scanning or seeking. When you go into the query plan, you can't really see it yet until you see convert implicits, and that's where you know you died. But the reality is that every column has a data type, and some columns have precisions and scale. And whenever you're comparing, if you've ever tried to compare a lemon versus a lime, or the famous one is an apple and an orange, and people venture down that road and say, well, it's round. Well, I mean, is it really? No, okay, that can't be done. It has a color. Okay, that's just a description. That's not comparing them. One's yellow, one's green. Oh, okay, but that means they're not equal because they're not the same color. So I have a green lemon and a green lime. I still can't compare them because they're not equal. The lemon is never going to become a lime. A lime will never become a lemon. So there's no way to compare them. And SQL Server is no different. A varchar is not the same as an nvarchar. It just isn't. The only difference is the n, right? No. It means there's an extra character, which is hilarious that it's varchar and nvarchar, because the difference is that nvarchar has an extra character, and it does in its name as well. So that's how you can remember. But nvarchar is Unicode, so it has 2 bytes per character. and a varchar doesn't. Varchar has 1 byte per character and deals with only ASCII sets of data. So if it's not in the ASCII character set, it won't fit in a varchar. It needs an nvarchar. So if you try to set it there, it will strip off the bit. But the big deal is you can't compare a varchar to an nvarchar. And SQL follows that rule. There's a link in the slide deck for the data type precedence, and it will tell you what data types elevate to what data types. So if you were comparing an int to an nvarchar or a varchar, an int has a higher precedence than a varchar and nvarchar. So it will try to elevate every varchar or nvarchar into an int, and then it will do its comparison. We'll show you what that looks like and why you don't want to do that. But data types are huge whenever you're declaring a variable and you say varchar 50, and the column you're going to compare it to is a varchar 250. They aren't equal. They're not the same length. They will never equal. Your varchar 50 will compare with the first 50 characters of the varchar 250, and that won't make them equal, especially if there's 52 characters. It'll blow. So just remember, data types are the king when it comes to data. So type them right, as well as when you do code, make sure that type is equal to type, and you will avoid these convert implicits in the query plan, which could cause a query scan or a table scan. Triggers. There's really not much to say, except there's a big trend that I see with a lot of old style triggers. Whenever you go into a trigger, you have 2 modes of operation. Besides the insert, update, delete, the way triggers work is if you did an insert, an update, or delete of multiple rows. So say you did 2 rows, and inside the trigger, you handle it like it's 1 row. You will have some weird things happen. The biggest weird thing is the update. So if somebody wants to know if that column was updated, don't do this. Or if it was updated, do this. The problem is when you have multiple rows, it won't act the right way. In fact, Brent Ozar just did something recently about this thing on his blog about update being a wild ride when you have multiple rows. So no concerns when you treat everything in triggers. If there's only 1 row, that's great, but assume you always have multiple rows and handle it accordingly. Doesn't mean you roll out a cursor in the trigger, but just be aware that you should be dealing with multiple rows, and that will help you save a lot of heartache in the end. Identity and sequence. There's really not a lot to be said, except these are really old. The identity's old. Sequences have been around since 2005, so they're kind of old too. Identity, they began back in the olden days because that's what Sybase used before SQL Server became SQL Server. But the most common thing I see is people using @@ identity. Now, there's all sorts of content out there on the snafu and why you wouldn't do that. That is a global variable. That global variable gets set every time an identity gets retrieved, no matter the scope. So that's the bug. If you have it is scoped to your batch, but it's still scoped incorrectly, because if I have a insert into a table, I insert 1 row, and that table has a trigger, and inside that trigger, I insert an audit record to say that this ID was inserted, and it has an identity column in that table. The @@ identity that you do after your insert is going to have the triggers identity, not your table's identity. That is a kicker. So they have the scope identity, and scope identity will keep you in the right scope. And the scope is you are running the insert. The trigger is behind the scenes in a different scope. So you won't get that identity from the audit table. You will get the scope from your insert, which is exactly what you want. Now, there's a couple bugs in that too, but you're going to look those up and see if you'll ever reach those race conditions. But that's a big deal to understand where you're vulnerable and where you're not. Sequences, those of you who aren't familiar with them, they're an object and they're in a schema. So DBO my sequence, I create my sequence, and I'll show you this in the demo. You create your sequence with a data type. So in this case, I would do an int, and I would say start with, and I can start with any number, just like identity as a 1, 1 that starts at 1, increments by 1. I can actually do for a sequence, start with 1, increment by 1, and it will do the same thing. Now, the difference with sequences is that it does have a caching mechanism. By default, it caches, and depending on the version of SQL, but it does cache 15 at 10 or 15. I can't remember now. 10 or 15 sequence numbers for you so that they're fast access. But basically, you access them with next value 4, and that goes in a default condition. So if you have create table and you want an identity or a sequence value on the ID column, you would create a default that says default is next value for my sequence, and it will pull the next value out. And it's pretty resilient as far as speed of getting the next value without blocking and locking, just like identity would be. Identity is a little more heavy, but it's the same principle. The big deal about sequences are that you no longer have to have set identity insert on to the table in order to insert data in there without worrying about the identity being there. So you can actually have values from another table that have identity values that are not conflicting with anything of your primary key, if your ID is a primary key, and it allows you to insert data from one table to the other without having to turn set identity insert on and set identity insert off. This is a free table that just so happens to have a default for the ID that has my sequence. So it's kind of cool. But that's what I use now. I don't know that that's a very common thing to see everybody using only sequences. The other value for the other value for using sequences is that the sequence is external from your table. So what if you wanted to make sure you had a unique value across all your tables for your identity values? You could get next value for my sequence in table 1, table 2, next value for my sequence. You get 1 in 1, 2 in that next one, the third table, 3, but then the table 1 gets another one, and that's 4. And now you can keep your values unique across all your tables that you want to. Now, I've heard that that's not as common, but there's been people that have needed it, and this works out great for that. So that's another value, is it's not linked to the table. It is a separate entity that doesn't have to worry about anything like identity does. SARG, really, we're going to see it in demo. It's not really a big deal. It's just a principle that I want to illustrate because this is a big deal for performance. And there's a lot of query plans that people look at and go, why did it scan my table? And there's plenty of reasons why when people use functions in their where clause, and there's plenty of ways to do that. We'll show you some of the ones that you can do that with. And then feature use. Really, this comes down to when you're doing something in SQL, there's 2 ways you can think about writing SQL code. One, you can write it very generically. And it's actually very common to write generic code because you want it to last and go through all other engines. So you want it to work in MySQL, you want it to work in Oracle, you want it to work. That's a pretty generic case of coding. And honestly, when you do that, you sacrifice speed. I mean, that's what you do because you can't use a feature in SQL that's not in Oracle, that's not in MySQL. So you start to limit yourself on what you can do. And maybe even the syntax is different. So now you have to do this convoluted thing where it's just not pretty. So trying to be compatible with all is probably the wrong move when you're developing software, especially when interacting with a database that needs to maybe be speedier. Is null is one of the examples. Some of these right here, string split using graph. Not all databases have graph capability. Not everybody has a hierarchy ID because it's a CLR data type. So is file stream. So is that really a good idea to omit the values of these features just because you want it to be compatible with Oracle? It's almost better to have 2 different versions, one that works with Oracle, one that doesn't, and that works with another engine. So that's what I see out in the wild. String split is new in 2016. Offset fetch has been around for a while, but a lot of people don't even know what that means. The people that use MySQL, the limit function is really nice for them, and they love it, and they use it all the time for paging. This is a paging feature, and it's really kind of handy if you only want 20 rows out of the 50,000 that you're going to return, and you want to page them. You can do an offset fetch, so you can offset by 50 rows and fetch the next rows. So it's really kind of slick. You can do 50 at a time if you want to with offset fetch. And there's tons more. But what I've seen in the wild is people writing their own split functions, and they're out there. There's some super fast ones. Jeff Moden has one. there's lots of them. They use tally tables. They're all nice, but even compared to some of those that are out there that people tout as really, really fast, and I love Jeff Moden, but the string split was built super fast. So we did an example, and it was literally a second to do a DBA split or DBA whatever FN split that's out there, and then you use string split, and it was a millisecond. So very vastly different when you're messing with sets that are common delimited. You want to split them out into a table and join them or whatever. Features can sometimes just make all the difference in the world for your speed and use of your SQL Server. So that's all I have for slides. So let's go into our demo and see. I'm going to have to, let's see if I can share my other window. There we go. All right. So we have this SQL Server. I'm going to use Azure Data Studio and make sure that we can do that. I'm going to minimize this little terminal here, guy, because I don't need that yet. I probably won't even need it at all today. So we'll just split it with just like Management Studio. I was doing some PowerShell stuff, so I decided to stay with this and I didn't download and install Management Studio, which I probably could have. But all right, so the first demo here is the idea of the assignment statements. So we have a demo DB, which we will use today, and let me create my demo stuff because I believe this is a brand new database. So we're going to do that. Good. All right. So a single assignment statement. We have a declare ID int, comma, name varchar 10. We set ID equals 1. That's a single assignment statement. That's an ANSI way. And then I can select ID to see what it is. So it's pretty simple. I should get 1. Yep, I get 1. Great. Now I want to do select ID 1, name equals Ben. And that's an assignment statement there. So let's do that and we'll execute that. And look how much code that took. I mean, I could have just declared them and then selected them or something. But I mean, but to illustrate the point, you can select and do 2 at a time, where this is just 1. So that makes sense. Now I'm going to declare these, and I'm going to select 1. I want 1 to go into the ID from test table. This is an ANSI way. This is what I was telling you about a subquery when you select it. So if I say select there and I run, I got an error. Subquery return more than 1 value. This is not permitted. Now, remember when I said this is ANSI, and ANSI says you can set 1 and only 1 value to 1 and only 1 variable. And it just so happens if I were to run this particular query individually, you'd see that I have 2 rows. So I was cheating a little bit, and that threw an error when I said select with 2. So that's just ready to be understood that you will get an error here because there's 2 rows. Now I could say top 1 and that would solve it. But again, top 1 without an order by really is not that awesome. And if I'm going to do a select with a where clause, why don't I just do it in the where clause alone? So anyway, that's interesting. So if I do a select from test table, you'll see that Ben and George are in the table. So that's why it's that way. So let's go down and we will check out what happens when you use a select that returns multiple values. And this is the red herring I was talking about. So we're going to declare name, and we're going to select name equals field from test table. Now you already know there's 2 values in here. So which one is it going to get? So we're going to try it out and see who's going to come out, Ben or George. And you should have picked George because it is the last one in the table. Now I didn't do an order by. If I would have done an order by here and said order by field and said descending and then selected it, you would see that it's actually going to come out Ben, because I ordered it George, then Ben, and Ben was the last one in the totem pole. Now imagine if you were doing this with a 1,000,000 row table, which please don't do that unless you have a nice lookup column that is unique, like if you're doing it on the primary key. The reality is you get the last row value whenever you do a select field here. You want to make sure that you are using a unique key here if you're going to pull data out into a variable. It won't error like set errored. Remember when we did multiple rows, set errored and said, hey, you dummy, you're not supposed to do that. But this select won't. It will just go to the last row of the statement and assign the last value of that column to the variable. It's that simple. But if I said where field, and this is contrived, but if I said where field equals Ben, there's only one row as Ben, and actually that works because I will get Ben. So just remember that it's very important. And this is what we did before: select, and then a top one, it will come out. But top one without an order by is guess who, guess what comes out. Who knows? In this case, it came out with 2 Bens, which is helpful. And if we were to do it with this way, we already showed you this, where you'd get a value top one field. You wouldn't get what. We'll run this guy here, and you'll see that you actually will get 2 values, but you get Ben because you said select top one, but you didn't do an order by, so it got the last value. Just depends on what ends up happening. Here's the update statement. So we have a table with Ben and George in it, and we're going to set the field equal to Bob, where the field is equal to George. So we're going to change George's name to Bob because he wanted it to be shorter. So we're going to basically declare the name variable, and we're going to update test table, set the name variable equal to the field, and field equal Bob. So we're going to change the field name to Bob, and where field is George. So we're going to affect one row, and we're going to see what comes out the pipe. So you can guess in your own room and find out what you're going to guess what comes out of name. You can choose any name, Ben, Bob, or George, as to what's going to be in this name field. And then we'll talk about it. So I'm going to execute this, and sure enough, name became George. Now, why not Bob? We said where field equals George, so we were very specific, and there should have only been one row. And the reality is name was set equal to the field. So why didn't I get Bob? I set field equals a Bob. And I could even reverse these and put field equals Bob first and name equals field second, and then where field equals George, I'd still come up with George. And the reason is, when you look at this table, Bob has definitely taken his place over George. But the reason why George is in there is because this statement hasn't committed yet. So I'm getting the value that was there first. And then after the commit, it becomes Bob. So I get George in the variable and Bob in the table. So that's kind of a tricky way, but it's one of those things where tricky does work. It just depends on how you want to do what you want to do. All right, so let's do this next demo with schemas. And I think it's not going to work because I don't have, oh, no, I do create a schema DBA. I don't create my login. So the test login, so we won't be able to test this one. But basically what happens is I create a DBA schema and a DBO schema. And I create a test table called test schema and test schema, one in DBA and one in DBO. So there's a DBO and a DBA. And what happens is this DBO, when I log in as this user called test login, and I'll make sure that I have the other script that usually I should put create a login here, and I didn't. It's easier in Management Studio than it is in Azure Data Studio. But if I had a test login, basically what I do is I set the test login default schema to DBA. So when I do a select star from test schema, notice I don't qualify it. So it's going to look in my default schema. And in the data, I actually put DBA in the DBA schema and DBO in the DBO schema. So when I select this guy out and say just test schema, because my user has a default schema of DBA, it would come out with DBA. Then I execute, I execute this as me. So if I ran this, I would get DBO because I'm a sysadmin, and sysadmin's default schema always ends up being DBO. Execute as user test login, which I don't have, but once I do that, I execute a login and I say test schema, it would give me DBA first, unless I said, give me DBO, and then it would give me DBO, and then I revert that login. So I'll make sure that that's in this demo here. But basically the principle is if you don't qualify your objects with your schema, you get what SQL Server figures out you should get. If you really intended to get the DBO schema's data, don't rely on your default schema. That's terrible. That's corruption in your data results, right? That's bad data. So specify the default of your query to be what you intend it to be so that you get what you expect. Okay, that's the most important piece. All right, data types. I have already prepped this in, so I want to make sure we see this. And oh, you know what? I should have, crap. We have enough time. I'm going to download Management Studio while we do this other one. I knew I needed Management Studio for something because I have not mastered query plans in Azure Data Studio. So that's my bad. So let me pull that down and we'll just let this go and we'll install it in just a second. Actually, it's moving pretty fast, so I might just quickly install it. Or just get it installing and then we'll go from there. All right, so let's just get this installing here and we'll use this in a second. I'll show you some of the tricks of why you care about data types. Come on, VM, you can do it. All right, let's run this and we'll just get that installing. Yeah, this is what you get when you set up a brand new machine for your demos before. Oh, and it's not going to let me run it while this is running. That's great. We'll do that in a second. It shouldn't take very long. It's just install. So basically, we're going to do a demo here later on that. So let's do identity. All right, so identity, we're going to set up this guy here. And we can just use the demo DB. Yep, that's good. And we'll do here. All right, so the demo is set up so that it will, I don't know why they do that so high. There we go. So the demo is set up that we have two tables, table 9 and table 10. So we're going to select add identity here, and there's nothing, so null, we're good. If I were to insert this data here, I don't know why it's there. Okay, this is how you call them. That's why it's there. So add identity as identity, well, you might select that, or scope identity with a parenthesis. Don't forget that because that's a function. So it's an internal function. So we're going to set identity insert on table 10 on. And we're going to insert this special thing. This is what happens to identity when you do that. So 200,010 is your value here. And then I insert into table 10 and I do the identity value 5. Okay. So here's what happens with identities. This is the first demo that will show you some of the side effects. So if I identity insert, we already said that we've set the identity seed in table 10 to be 200,000. So if I were to insert a row, I would get, oh, there it is. There's the insert table. Say, we'll do this. We'll run these three right here first. No, I'm already in table 10. We got to get through that one first. So right now I inserted a 200,010 and my scope identity was 200,010. Now what would happen if I inserted another row into this table? So let's just do that. Let's just copy and paste this guy. And we're going to turn identity insert off for a second. And we're going to insert this guy and we're going to take away the ID and name. We're going to do name because identities to let me not have to do that. So Jerry 3, and take away our identity. And we're going to see what the scope identity is now. Now remember, we reseeded it to be 200,000. So I should expect 200,001 because I inserted 200,010. So I should expect 1, right? Well, that's not all true. If I run this, you'll see that I get, didn't I turn it off? Let's see, might have not turned it off. There we go. So let's insert this. And if I do scope identity, it should still run 200,011. So it didn't go back to 1. I said, but because I set identity insert on, one of the side effects is that it takes this as the new seed because I set identity insert on. So that's a side effect that you need to know. Now I'm going to turn it off or on again, and we're going to insert another statement in here. So that's on now. And now I'm going to do this guy here and watch what happens when scope identity gets called. If I insert this guy now, my identity is now 5. So imagine I reseeded it to 200,000 and now it's actually reseeded itself to 5. So what's going to happen when it hits 200,009? The next value is going to be 200,010, and your primary key or your unique key will break and you'll get an error. And then it will proceed with 200,011 and it will break. And then 12, and 12, it will move on and be fine. That's a red herring waiting to happen, and you don't want those things. So identities can be a little weird, psycho, crazy, but you do have the ability to do reseed. So we could go reseed this back to 200,012, and then the next value would come up and be fine. So just know that that's something you have to be aware of when you mess with identities and you turn this identity insert on. It actually will reseed your table. So it's kind of cool. All right, so let's do this and get it off there. And then we're going to insert into the table, and notice the scope identity is 200,012 now that I turned it off. All right, so I have weird things in the table. I have 200,010, 11, 5, and 12. So weird, but now this is a 2019 instance, so it does look like it actually changed the behavior. After I turned this set identity insert off, it went back to 200,012. So somebody must have filed a bug, because that's not what happened in 2016 when I did this demo before and worked out that. So next demo. So let's do this. Let's exit out of here and let's run the setup here to get this installed. And then while it's installing, we'll look at another setup. All right, there we go. Good deal. All right, so let's go back into our demos. And we're going to look at Sargability. Now, when we get Management Studio back up, we will run it. I don't want to mess it up with running it while we're running that, but we'll make this a little bit. All right, so we have AdventureWorks. And you know what? I can't actually run this without Studio. Where are you at? Oh, okay, we're almost there. We'll just take a break. Do you have any questions? Let's look in the questions thing and see if there's any questions.
No questions yet, Ben.
No questions yet. Wow, I'm just killing it. That's awesome. No one has any questions. I try to be thorough, but sometimes it's just, and look at that. We're downloading, we're installing 18.7. Wow, they must have dropped a new one. Very nice. Thought it was only in preview, but we'll walk through this and then we'll run it. So we're going to set statistics IO on because we want to see how many reads we do for this table. So there's a purchasing schema and a purchase order header table. And so I'm double part naming, and I'm just going to select order date where the order date is between get date minus 3631 and get date minus 3600. So 30 days or 31 days of data behind me. Now I did 2012 with this date this number of days behind because it's an old database and they haven't put new data in it, and I didn't modernize the dates. So we get what we get when we start flying through it. Okay, it's still going. So this is the two queries we're going to run. We're going to see if this works the way it does. We're going to see how this works. So I'm dealing with behavior here. How does SQL operate when you do this with a between and a get date in the where clause? And then we're going to do a date variable, that's a date time, and a date to variable date time. And we're going to select the date equals get date and the date equals get date. And then we're going to use those two variables in the query. Okay. So this is going to be really important to note how it works. You'll find as you attend my presentations or look at my videos that I've created, I'm more of a behavioral science guy than I am a right or wrong way. There are some things that are right and wrong, but take set and select. I don't know that I can say that set or select or even update is the right way to do it. We could always inflict our opinions on other people. we have that right to inflict our opinions, but the reality is right and wrong really in SQL is all about, does it perform? And even then it may still be right if it doesn't perform as good as other stuff. But the reality is right and wrong don't have a play in coding. There are things that are syntactically incorrect, which the engines would flag you to say, I'm sorry, you can't use that, right? So that's real. But the reality for me is that the right and wrong really doesn't fly. So in this case, the right and wrong for date and order date, the date between function and the date between variables, you'll see will become very evident as to why that is important to understand what goes on. So let's have Management Studio come up. It usually takes a while to run first. All right. Unless it disappears. If it disappears, then we are in trouble. Okay, there we go. All right, so we'll do SQL demo, and we'll actually bump up our little font here. We'll just say we want the grid view, grid results to be a lot bigger than 8. Yep, we know. And then we will do a query. We'll bump this up. Go into DemoDB. We'll open a data file here. Demos. And we'll go into our Sargability. All right, so we have this guy, and let's just see if it comes out as okay. It's big. Okay, good. All right, so we're going to use AdventureWorks. We're going to create our index, and we're going to use set statistics IO on, and then we're going to do this with a query plan on. Whoops, not estimated. We'll do the bigger one. There we go. Execute. And you'll see the order date doesn't come back, and I guess we're going to have to go back further. Yeah, we're going to have to go further, and I knew this would happen. On this database, we are compatibility mode what? We are in 2012 compatibility mode. It should have acted nicely with this, but it looks like let's do 4,000. Well, 4,000 there and 40, 31 there. Because according to this, it is still seeking, which really drives me crazy because, yeah, it only did 2 reads to find out nothing. Let's just see what's in there. There's 4,012 rows, and it's 430, 2011. Oh, yeah, wow, that's not 4,000. Let's do a select here and find out what that date is. Wow, they've really limited their, I should have got the DW. Boy, that's not very big. 2009, yeah, so that's not going to help. Let's just do 2009. We'll just do, how about 3,000. Should get some, oh, sorry. Should get some rows back now. Yeah, there we go. So 212 rows. We should have seen a scan because it's a function, but this function apparently has been optimized for in 2019 engine. So unfortunately, we don't get to show that. So I should have done this on an older version of SQL. Even the compatibility mode doesn't stop it because the engine has very smart optimizer. So let's go here and let's do legacy cardinality estimator and just see if that changes anything. legacy on. Nope, still seeked. So we get the benefit of features. Now, remember when I told you that in the presentation that you should use features that exist in SQL? This is one reason why. The features of 2019 in the optimizer and the execution engine, they actually have intelligent query processing now. So there's ways to have this optimized out. Anybody who's done an in where order date is in a certain date, the optimizer will actually turn those into ORs for you. You don't have to do it for yourself. It does it for you. There's plenty of optimizer enhancements like this to take this out of bad land and put it into good land. But say you had a function that basically went and got a date from passing in the ID, and you said fn get ID, and you passed in the order ID. Didn't do it. Or purchase order ID. If you did that and you had this function defined, it would have to process every one of these before it could compare. And that's where sargability dies. When you have functions in here, when you say is null, we'll just do is null, where order date is equal to is null. Order date, get date. So now I have this is null function, and let's see what it does for our query plan here. It index scanned it, right? So the scan is because it used a function that it could not tell. There was no way to tell that there is one way for this to actually make it work. And that is this order date. Oh no, it is not null. Very interesting. So it did not optimize this out. So this is not an optimizer feature yet, but if you use is null, it will scan instead of seek. But if I change this query to be something like this and said select where order date is equal to get date, because we know it's optimized out, or order date is null, then we circumvent that guy and we seek. Seek. Because I no longer have a function that is not done, but it did the same thing as my is null. Same exact thing. So those are things that you have to worry about when you start thinking about functions inside your fun little where clauses. And this goes for join clauses too. There's plenty of times I've seen that join clauses have the wheres in there without the where word and says something equals one or something equals is null something, and it becomes part of the joined clause. The optimizer knows how to pull those out and make those where clauses, but where you put them matters when you do left joins and right joins. So you just be careful of how you use that and make sure you do the right thing. So that was fun little adventure. Let's open up another one and let's go into the query plans and schema. All right. So, you know what? We're running a little short on time. Actually, we're covering everything we want to, so that's kind of good. Let's make sure there's not another one. This one's usually the last demo. Make sure. Oh, we don't have one for triggers just because, just because the concept is not really awesomely demoable. I could put a trigger on a table and then insert 2 rows in and show you what update does. But again, Brent Ozar did a very good blog post about that, so you can go read it there. So we'll just finish with this demo. This basically is the idea of the plan cache. And this is not in the slides, but it's something that you do need to be aware of. Optimize for ad hoc workloads is a server setting that is off by default. So you can turn it on. This is going to turn it off to make sure it's on. I usually turn it on every one of mine by default, just to get myself going. But the 0 I've turned it off right now for our use here. So we're going to free the proc cache, which you should not do in production regularly or even accidentally or at all. There's times when you will, but I would recommend you flushing cache for a database before I'd ever do a free proc cache for everything, just because it's pretty impactful. So we're going to see that there are no plans in here except for what we just did. So we just ran the query, and if we looked at syscache objects, you'll see that it has the text in it. So if we scroll over here, you'll see the text. So there's a create function of sysdm exec SQL. There's dm exec. There's create view. There's select. So there's really no user queries that are in here. But notice the SQL bytes inside this plan for the first execution is very small. It's only 300 something bytes, not very big. When we come back here, we're going to do a basic query here. So we're going to select the star from the test table, and we're going to do that from our DemoDB database. So we get two fields, and we did change it from Bob to George, or George to Bob. So we have that message there. And so we have two. And now we're going to select the same thing, select from test table. And now we're going to view the cache objects and see what is behind there. And if you'll notice, we'll get some pretty big, wow, that's a lot of data. Yeah, that's a lot. So let's scroll up here, and you'll see that we have, there's some parse trees for the views. I didn't really realize the views would be that impactful, but we're going to go look for our queries. So we ran two queries. They were the same, right? Test table and test table. So we should see that in here as test table. And sure enough, if we get down here, we'll see, oh, maybe, wow. There's select star from test table, and the SQL bytes are 58, and the plan bytes are, where's my plan bytes? Not very nice. I don't see my plan bytes. Let me grab the query here. So it's right here, 69. And it's 12,391. $12,391. We'll just do this. Where bucket ID is equal to 12,391. And we'll see that the size is 40K for that one little select star from test table. Now, what if I ran it again? It's still 4096. Why is that? I ran the same exact query. Well, if we go back and look at our query objects here, and I'm just going to select out bucket ID, SQL bytes, and text. Nope, that's not what it's called. SQL. So I scroll down here to my test table and see that my test table is here. There's 58 bytes, 12,391. But there should be another one. Oh no, because I have it off. That's right. So this guy, test table, 12,391. I'm going to go turn on this guy with 1. Only got 1 minute left. We're going to go fast. Free proc cache here. We go execute this guy once. We still should be able to see it in bucket plans or bucket ID 12,391. For whatever reason, it's really good at that. I'm not sure why, but if you did where bucket ID is equal to 12,391, SQL's pretty good when you're, demoing. Not on a system that's huge, but demoing, you can usually get it. So it's 58 bytes. But now watch what happens if I run the same exact thing again. It's not the same anymore. select star from test tables, 58 bytes. But look at this. I go, oh, look at that. There's another one, test table. It does care about the spaces and everything. What I did there was I included the comment. Even if I would have included a carriage return line feed or space, it would have been a completely different query. And if I would have changed cases to this guy and said with a capital E, even though in a case insensitive server it works, I'm still sad because it's a new query. I have test table E and test table. Dang it. They're still 58 bytes long, but these are two completely different queries as noted in the different bucket IDs. So beware, cases, the query cache is case sensitive, and it does matter that you have case sensitive stuff. So beware of all the fun that you can have with SQL. Don't tease it. It's a nice engine. Behave and be kind to it, and it will be kind back. We'll go back to my slide deck where you guys can get the, I guess I can't. Oh, there it is. Where you can get my contact information at the bottom here. And you're welcome to contact me, and hopefully you'll have a good rest of the day. Hopefully this conference has been great for you. It's always a good time. Pat does a great job with organizing it, and we get some great sponsors to help us out with prizes and stuff. So get involved and have fun. Hopefully we'll see you out in the data community.